All right, hello, Dr. Ruby. This is my critical review presentation. It's the image enhancement of homogeneous background images. And of course, I'm Joshua Garcia, and this is for our machine vision class. So today we're going to be going through just a critical review of a paper over a image enhancement method. And we'll begin with an introduction and go through a methodology. We'll talk about the Rényi entropy mathematical formulation that they used, which was a piece, just one part of their algorithm. We'll talk about the results of contribution, the strengths and weaknesses of the paper, and we will conclude. So the paper was titled A Systematic Approach for Enhancement of Homogeneous Background Images Using Structural Information. And there were two authors, Vijay Yalakshmi and Nath. And their problem could be boiled down to this statement: what image enhancement method can be used on images with homogeneous backgrounds and yet display crucial data that could be potentially obscured by light scattering or absorption? And they talked about working with images with just kind of plain backgrounds and the different effects that can go on when trying to use image enhancement methods. And some methods produce image artifacts, and others just don't work as well. So they wanted to provide one that could work with homogeneous backgrounds and clear up some of the data. And some of the results are pretty substantial, and we'll discuss that in a moment. The mathematical formula that they did follows this path, where basically they start with a low contrast image, and they create a histogram of the related pixel values, the intensity of the pixel values, and then they create a two-dimensional histogram where the original histogram goes through essentially being cut in half. The data revolves around the median value of the brightness. That's what they did with their algorithm. And then they go into the Rényi entropy. They compute a discrete function, and they do what's called subhistogram clipping, enumeration, integration, equalization, subhistograms, and they also perform local contrast enhancement. There's a lot of mathematics that goes behind all of this, and it's there in the paper. The next slide will discuss the Rényi entropy with a bit more detail, but all these different things, they affect the image. The image goes through all these different steps. The pixel values are used. They funnel through these different mathematical formulas, and it eventually produces a high contrast output image. I know for sure that there's a lot of sums going on, weighted values, there's cosine, discrete cosine transform that takes place in the algorithm. But in particular, there was this thing called Rényi entropy, where the R variable represents the output of the Rényi entropy, and they split the histogram data up between two halves, with the median value in the middle. And so this would be performed to both halves of the data. The H sub L represents a 2D histogram, the chosen side. The alpha variable represents the power probability, which was set to 2 in this case. And the values of P and Q are the locations of the pixel values. So essentially it's a double sum that covers the whole image, and it's a logarithm of that multiplied by some fraction, in which case it was 1 over -1. And so that's essentially the Rényi entropy portion of that. What's more important is the results that they got out of the particular algorithm that they used. And so the more blurry image is the original input image, so low contrast, and the image that they got is this more clear image. And in total, they tested 10 different images, and many of them, if not all of them, resulted in just overall visual improvement, greater distinguishable information. As you can see, like the berries are just more defined, more vibrant, less foggy appearance, enhanced color information, and there's a lack of image artifacts. And that was one of the things that they discussed in their paper, is just these, they chose 10 images, and they conducted experiments using other common techniques and they produced the output images of those and compared it with theirs. And overall, theirs were producing really good results. And this one was just a stark one. But there were other examples that were visible in the paper that displayed just the efficacy of the results. And typically, they embodied these positive outcomes. The strengths of the paper was, for one, the methodology section was really good. They kind of take you by the hand. They explain each step, each mathematical equation, and they even provide like a test image. Like, it was an 8x8 image matrix with basic brightness values, and they computed some values, and they explain the different steps. They show each equation for each step, and they explain the variables. And that was very helpful. They had over 90 images for comparison. So again, it was like 10 input images with 7 different techniques and the outputs of each one. And they also provided histogram data for most of the images. It was just a lot of compare and contrast that was just very helpful. However, they didn't provide any images that displayed where the algorithm would fail. And I felt like that was a missed opportunity to provide the readers with, some kind of discussion of, what are the times when it would be inappropriate to use the algorithm, or where would you not want to use the algorithm because it fails in this certain area. And then some of the acronyms weren't defined. But overall, it was a very informative paper. Just talked about the different techniques that are out there. And they were just very good at just explaining their algorithm and providing the mathematics. The mathematics wasn't very complicated, and they show you step by step. They definitely demonstrated their proof of a solution, and just displaying the different output images that they funneled through their own algorithm. Did wish that we could see some negative results just to see where the algorithm fails. Because otherwise, you think that it's just foolproof, when most likely it's not. But it does contribute very much so to the fields of image and object detection, namely medical diagnosis, surveillance applications, and manufacturing applications. They even mentioned that in the paper in the beginning, just the importance of image analysis. So that was the paper.